by looking our schematic diagram, we have our transformer, which is 6.7 to 1 step down ratio, and then we have two diodes to perform a full wave rectification. So by using a center tap, each diode will handle 1/2 of the AC cycle. So this is to ensure that the current will always flow in the same direction. And then we have 1000 microfarad capacitor for our filtering, and also we have 5.1 volt zener diode to keep the output voltage stable. For our Tinkercad simulation, our goal is to change 214 volt AC into a steady 5 volt DC. So in a real circuit, we actually use a transformer to step down the voltage, but because of the Tinkercad doesn't have any transformer component, we use a function generator to act as our transformer secondary coil. So here, for our function generator, we set it to 18 volt for the amplitude and also 15 Hz for our frequency. So as you can see here, we have a 3 oscilloscope. The reason why we use 3 oscilloscope is to show you that the changing pattern of our wave. So first thing first, maybe you can see it at our first oscilloscope here. It shows a sine wave, which is wiggle up and down. This is because the AC electricity is actually constantly changing direction, so that's why it goes up and down. So this is actually the power we need to process it. So next, the power will go through the two diodes, D1 and D2. They will act like a one-way valve. So the electricity will go forward, but it won't go backwards. So as you can see on our second oscilloscope, the wave now kind of looks a bit bumpy, which actually we call it ripple. So that's why to fix the ripple, we actually add a 1000 microfarad capacitor to act like a storage tank to fill the gaps to make the wave more smoother. So actually this actually can turn the bumpy ripple into a steady DC line. So based on our calculation in our report, we actually use a 1000 microfarad capacitor to keep the voltage smooth, and also a 418 ohm resistor to limit the current to 14.4 milliampere. This actually can protect the zener diode from damage. Finally, the power will reach the zener diode and also the 1k ohm load resistor. So the zener diode will act as a regulator, which is its job to lock the voltage at 5 volt. So even the load resistor uses the power, the zener will keep the voltage from changing. So that's why at the third oscilloscope here, you can see our wave now is actually at a perfectly flat line. There's no bumpiness. So as you can see on our oscilloscope, we actually achieve a steady 5.18 volt, which is actually near to our theoretical target, which is 5 volt. So this actually proves that our circuit works just like the theory that we learned in class. To conclude, our project was a success. So that's all from Group 4. Thank you.